Hey everyone, welcome back, and we're now on to question 25 in the FICOS-MA 2019 B test. Last question. A student makes an estimate of the acceleration due to gravity g by dropping a rock from a known height h and measuring the time t it takes to hit the ground. Neglecting air resistance, which one of the following situations will lead to the smallest value of the relative uncertainty, delta g over g, in the estimate? So first of all, let's write down the equation to calculate g based on height and time it takes to hit the ground. Obviously, we would just use the kinematic equation delta h is equal to 1/2 a, well actually it would be g in this case, g t squared. So g is equal to 2, just call it h to not get it confused with uncertainty because it has a different delta, divided by t squared. So this is our equation to calculate g. And the error will propagate through the errors in h and the errors in t. So the question is asking us which situation will give us the smallest value of relative uncertainty in the estimate. So the relative uncertainty in g, which is delta g over g, if we recall our equations for uncertainty, since this is just a division, we have the uncertainty in the product 2h divided by 2h squared plus the uncertainty in t squared divided by t squared squared. Okay, and we can simplify this down further. Delta, the uncertainty in 2h, if we just take the multiple, is actually just, if we remember the equation for multiplying it, it would just be delta h over h. So then if we can simplify this down further, that gives us that the uncertainty and the 2h product is equal to 2 times the uncertainty in h. Okay, and we also can simplify this one down further as well by noting that the uncertainty in t squared divided by t squared, right? Because this is all just relative uncertainties, and this should be formulas that you memorize. It's equal to the power, which is squared, so that's 2 times the uncertainty in t, so uncertainty in t over t. So here, I'll write down all the equations again so everyone can be on the same page. If we recall, if we take the product of two numbers, a times b, then we'll call the product as p is equal to a times b. Then the uncertainty in the product divided by the actual product, this is called the relative uncertainty, is equal to the square root of the uncertainty in a over a squared, the relative uncertainty a plus the uncertainty b over b squared. And this also applies for division and however many terms you have multiplying and dividing. And for, let's just write this down as well, for powers, so we'll call this the exponential, a to the power of 2, for example, or actually we'll just call this b. The uncertainty in the exponential divided by the actual exponential number is equal to the actual value of b times the uncertainty a over a. Okay, so in this case that is what we get, and we can simplify this down further. The uncertainty in t squared is equal to multiplied by t squared on both sides, so that's 2t delta t. Now we can plug this stuff back in to simplify it down further. So delta g over g, which is the relative uncertainty in g over g. So that's what we want. This is equal to the square root of, so I'm going to plug this thing into here. So that gives us 2 delta h over 2h squared plus plugging this into there as well. So that gives us 2t delta t divided by t squared, right? So what we get, if we simplify this down a bit further, these guys cancel out. And these guys, this t cancels out with this squared, so we get square root of delta h over h squared plus 2 delta t over t squared. So now let's look at the answer choices. So this is the relative uncertainty in G. The answer choices is we're looking for the following situation that will lead to the smallest value of relative uncertainty. So in the case that there's no uncertainty and h has 10% uncertainty, then we have this term is equal to 0, right? Because there's no uncertainty in t, so delta t is equal to 0. And there's 10% uncertainty in h, relative uncertainty, which means that delta h over h is equal to 0.1. So we get that delta g over g for question choice A is equal to 0.1. And if we actually look at the other choices, if t has a 10% uncertainty, we see that we have 0.1. So we have this thing is 4 times delta t over t squared, right? Square root of this, right? So that this is equal to 2 times the delta t over t. So basically, if we have a relative uncertainty in t, if we have a 10% relative uncertainty in t, we're multiplying it by 2, so the delta g over g is equal to 2 times 0.1, or 0.2. So this is actually a larger uncertainty than A. And it turns out that that means that this has a higher uncertainty and that this is a better choice than answer choice B. And you can also show yourself that if both t and h have a 5% uncertainty, also it will be a larger uncertainty than where there's no uncertainty in t. We basically, because any uncertainty in t is multiplied by 2, so we want to have the least amount of uncertainty in t as possible. So this is wrong, and these are also wrong. So that means that the answer is A.